This video is about congruent triangles. Congruent triangles are triangles that are the exact same size and shape. I've got 4 triangles here, and they're all facing in different directions, but if I was to pick up one of them, I would be able to place it exactly on top of another. So all of these guys fit exactly on top of each other. They're different colours, so they have different features, but they have the exact same sides, and they also have the exact same angles. Now we've already seen that triangles that have the same angles can be considered similar, but if they also have sides of the same length, then they're congruent. Note that identifying that all the angles are equal, like you can do in similar triangles, is not enough to prove that 2 triangles are congruent. I have to prove that all their sides are the same. Now, I'd be able to see that for definite if I had all the measurements of the sides, but sometimes I mightn't have that information available. So there are other shortcuts to tell if triangles are congruent or not. So besides SSS, another way of identifying that 2 triangles are congruent is if I can show that they have 2 pairs of matching sides and the angle between those sides also matches up. And that is side, angle, side, SAS. It's important to note that the angle in that case must be between the 2 sides. It's called the included angle. Another way of telling if 2 triangles are congruent is if they have matching angles and a second pair of matching angles, and the side between those angles also matches. This is called ASA. And again, it's really important, the side S has to be between the 2 angles. It's called the included side. This might start to sound a bit familiar to you from constructions that we've done previously. We've constructed triangles SSS, we've constructed triangles SAS, we've constructed triangles ASA, and you might also remember that we constructed right-angled triangles. Can you think what the 3 letters were in that case? Pause the video, see can you recall, and can you think what the 3 letters stood for? So here we have 2 right-angled triangles. The rule for the right-angled triangles is RHS. So the R stands for the right angle, the H stands for hypotenuse, and the S stands for any other side. So I've got right angles matching, the hypotenuses match, and any other side is also a match. And if I have this combination of information, then I know that the 2 triangles are congruent. And if you remember your constructions well, there's actually one other way that we could construct right angle triangles, and that was right angle, hypotenuse, angle. And so in this case, I can also use RHA as a way of identifying congruent triangles. Note in this case, the angle does not need to be the included angle, and the side does not need to be the included side. Notice that for the purposes of the diagrams, I've faced the 2 triangles in each case in the same direction, but it's quite possible that you might have a question where they're facing in different directions. So just bear this in mind. So here's an example then of showing that 2 triangles are congruent. So in this case, I can see that I've got a triangle ABC and a triangle DEF, and I want to show that they're definitely congruent. So I'm going to first of all have a look at the information. Well, I can see that this side and this side are equal. I can see that this side and this side are equal. And I can also see that this angle is the same size in both. If you refer back to the different types of congruency, which kind is this, do you think? So this is side, angle, side. So now I just need to make my series of statements to make it clear why the 2 triangles are congruent. So I'm going to first of all say, well, AB equals to EF. Don't forget, I need to give a reason. I can say equals to 7. I can also say that the angle BAC equals to the angle DEF. Again, I can give a reason, it's 70 degrees. And I can also say that AC equals to DE. And I can give a reason. They're both equal to 5. Next to each of these, I'm just going to make a note for myself. Well, this was a side, this was an angle, and this was a side. And this will be useful for me when I'm giving my final reason at the end. So having made these 3 statements, I can say this implies that the triangle ABC and the triangle DEF are congruent, but I don't want to write it out as a sentence. Instead, I'm going to use a symbol. And the symbol that I'm going to use is like an equal sign with 3 lines, and that's the symbol for congruency. The triangle ABC is congruent to the triangle DEF. Now, in our course, we generally deal with triangles being congruent, but any kind of shapes can be congruent. You can have congruent squares, you can have congruent rectangles, you could have congruent circles. As long as they're the exact same size and shape, 2 shapes can be said to be congruent. Here's another example. So this time I can see that from my diagram I've got a parallelogram, and the opposite sides are marked in as being parallel, and I've got a diagonal line drawn in. That creates the triangle PSQ and the triangle RQS, and I want to show that these 2 triangles are congruent. So the first thing that I'm going to do is I'm going to see if I can identify the pieces of information that match up in those 2 triangles. So the first thing that I note about a parallelogram is that the opposite sides are equal in length. And I can mark in that information on my diagram. And then I've got a couple of options about how I proceed from there. I could mark in equal angles. For example, I know that in a parallelogram, opposite angles are equal, so I could mark those in. Or I might note that this side SQ is shared by both triangles. Either of those observations are valid, and you can see that in the case where I mark in SQ, then I'm going to be able to use side, 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 SSS. In the case where I focus on the angle at P and the angle at R, I would be able to use side, angle, side, side, angle, side. Either approach is totally fine. I'm going to go with the side, side, side option. So again, how would I write this out? Well, let's just make our statements about what's equal. Notice that I've begun not by writing things down, but by annotating my diagram first, or filling in the pieces of information that I can see visually from my diagram first. That's always a good plan. So I'm going to say, well, PS is equal to QR. Now I've no numbers to rely on this time, so I have to give a good reason for it. And the reason I'm going to say is opposite sides in a parallelogram. And you might even recall this was one of our theorems that we covered recently. I can also say that PQ equals to SR, again, opposite sides in a parallelogram. And then finally, I've got this SQ side, and they both have that. So I'm going to really state the obvious there. SQ equals to SQ, obviously. And the reason for that is it's a shared side. If you prefer, you can say it's a common side. It means the same thing. So when I go down through what I've decided on here, I've got sides, sides, sides. So that explains my choice at the end. And I'm going to say, well, this implies that the triangle PSQ is congruent to the triangle RQS. And I can write down an explanation for my reason there. Side, side, side. Here's a question for you to do yourself. So copy the diagram into your copy and try and prove that the triangle AEB and the triangle CED are congruent, and pause this video, and when you're finished, come back and check if you were correct. Okay, so how would I go about this? Well, the triangle AEB, first of all, is this triangle at the top, and the triangle CED is this triangle at the bottom. and I want to prove that they're congruent. So I want to start by seeing what information I can match up in the two of them. So I can definitely say that these two sides are equal in length because of the fact that I've got a parallelogram. I can also say that this angle here, BAE, is equal to this angle here, ECD. The rule that I'm referencing there is the alternate angles rule. And you might actually notice that that is true for the angle ABE as well. It is equal to the angle EDC. And when I look at this diagram now, I can see that I actually have enough information filled in because I've got angle, side, angle, and the side is the included side. There is other information that I might have marked instead. I might have noticed that when I draw in the diagonals of a parallelogram, that the diagonals bisect each other. So I might have said that these two lines are equal in length for that reason, and these two lines are also equal in length. And in fact, I might even have noticed that the angle here and the angle here are equal because of the rule vertically opposite angles. So I've got a lot of choices. It's really just which ones do I spot first. So now I want to write down my statements. So I've stated that I've got angles, sides, angles, and then I can conclude. The triangle AEB is congruent to the triangle CED for the reason of angle, side, angle. And again, just to point out that I've chosen angle, side, angle, but there were other choices that I could have made from my diagram also. Any of the SSS, ASA, SAS, and although it's not relevant in this particular case, RHS and RHA can be used to prove congruency. C now as an extension for this question, can you prove that the triangle AED and the triangle BEC are congruent also?